A spring is suspended vertically from a clamp attached to a stand. The unstretched length of the spring equals 0.045 meters. A weight of 6.00 newtons is attached to the end of the spring, increasing the length of the spring to 0.165 meters. Determine the elastic potential energy stored in the spring. Okay, so there's three parts to this question. First, we need to think, okay, how are we actually going to get the elastic potential energy? Well, we can use the elastic potential energy question. We'll be given that formula in the exam. It's elastic potential energy equals 0.5 times spring constant times extension squared. However, the key thing is that we need the spring constant, and the spring constant isn't given to us in this question. Therefore, we're going to have to calculate the spring constant. We do that using the formula force applied to a spring equals spring constant times extension. Now, to do that, we're going to need to find the extension. So we'll do that first. So we say extension equals the increased length of the spring, which is 0.165. Take away the initial length, which is 0.045, which gives us an answer of 0.120 meters. Okay, so now we've got that extension, we're going to apply the force applied to the spring equation. So the force we can see there is 6, so 6.00 equals K, which is a spring constant, times the extension, which we've already calculated as 0.120. What we now need to do is rearrange that equation to find K, make K the subject. So we say K equals 6.00 divided by 0.120, which gives us an answer of 50 newtons per meter. Okay, so what we've now got is the spring constant. We can now apply the elastic potential energy question. So the energy equals 0.5 multiplied by the spring constant, which is 50, multiplied by the extension squared, so that's 0.120 squared. Okay, what can we now do? Work out that whole equation, and that gives us an answer of 0.36 joules. So this is a 6-mark question. Where do these 6 marks come from? So there's 1 mark for calculating the extension, 1 mark for the force applied equation, 1 mark for the rearrangement, 1 mark for the spring constant, then 1 mark for the equation calculating elastic potential energy, and 1 mark for the final answer, giving us the 6 marks available for this question. Now, obviously, this is a multi-part question. It shows you the importance of writing all your working out down and following stages through carefully. Because if you made one mistake, you can still get some of the marks from the methods from the various parts before the final answer. However, if you just wrote the final answer down or just wrote bits of method, you can really miss out on marks.